Hello everyone, in this video I'm going to do a quick demo on Terraform Providers. Provider architecture. If you see in this diagram, what we want to create? We want to create a new server in Azure. We already have a very detailed discussion regarding this one in Terraform commands video. Let's do a quick recall. We have created a file name called as file.tf. In this file.tf, I have created two blocks. One, it is for provider and the next one is for resource block. The provider block which I have mentioned, it is AzureRM, and the resource block which I have mentioned, it is for virtual machine. Then we are going to run a command called Terraform init. As we have discussed, the Terraform init is going to download the Azure RM provider in my local machine in a dedicated folder name called as .terraform. And then this Azure RM provider is responsible to connect to my Azure API. And then I'm going to run Terraform apply to create the virtual machine inside my Azure subscription. Let's firstly understand the semantic versioning. A semantic versioning is a versioning scheme used to convey meaningful information about the changes in a software release. It follows a standard format of x.y.z. X stands for major, Y stands for minor, and Z stands for patch, making it easier for developers and users to understand the scope and impact of updates. Major version represent breaking changes that are not backward compatible, incremented when old features are removed, major architectural or functional changes are made. Example, changing from 1.0.0 to 2.0.0. In this version, what we are doing a major change from version 1 to version 2. Okay, which means it is not backward compatible. Minor version represent the addition of new features that are backward compatible, incremented when new functionality is introduced, existing features are enhanced without breaking existing use case. Example, updating from version 1.1.0 to version 1.2.0. So what is the exact meaning? Here we have updated this minor from 1 to 2. So this is a minor version case and it is backward compatible. Patch version represents bug fixes, security patches or minor improvements that do not add any new feature or introduce breaking changes. Incremented when a defect or issue is resolved, small backward compatible changes are made. If you see, moving from version 1.1.1 to version 1.1.2. Here we are doing changes on patch and it is bug fix only. So if you see any software, if it is mentioned 1.1.0, then you're good to say this first one is major version, the second one is minor version, and this 0 is for patching. If any software is moving from version 8.0.0 to version 9.0.0, then we are good to say it is a major version upgrade and it is not backward compatible. So this is a versioning scheme used to convey meaningful information about the changes in a software release. Why Terraform providers like Azure RM have so many versions? If you see in this diagram, the latest version is 4.14.0. Around 4 months back, what they have done, they have released a major version. Then they have done one patching. And from last 4 months, they are doing minor release. So why they are releasing so many versions of Azure RM? The Terraform providers like Azure RM have so many versions because they need to keep up with fast-paced evolution of cloud services, user requirements, and bug fixes. Example, suppose Azure introduces a new service like Azure OpenAI and Terraform user want to provision it using Terraform. A new version of Azure RM example 3.116.0 would be released to include support for this service. If a bug is found in the resource implementation, a patch version, I would say 3.116.1 will follow shortly. When Terraform core makes significant changes like a new SDK, the provider might release a new major version 4 to include the breaking changes. So what is the exact meaning of it? Let's take example. If we are using this version name as 3.115.0, okay? Then Azure has released a new service called Azure OpenAI. Okay, do you think this service will be included inside this version 3.11.5.0? The answer is no. So the Terraform is going to release a new version, and the new version, I would say, it has released 3.116.0. Okay, and this version will include the OpenAI. If you want to use OpenAI using Terraform, then you need to move your provider version from 3.115.0 to version 3.116.0. That's why if you see there are so many versions present for Azure RM providers. Why? Because Azure is, I would say, Azure is continuously adding some features or removing some features. So our providers should be our Azure RM provider should be updated to track all these Azure changes. That's why our Terraform Azure RM providers has so many versions. And it is not specific to Azure RM. If you see any version of Terraform, they would have n number of releases. This is one of the major reason of having n number of version of Terraform providers. Hello everyone. In this video, I'm going to continue my discussion for Terraform provider versioning. Best practices for setting provider versions in Terraform. During Terraform init, if version argument is not specified, the most recent provider will be downloaded during initialization. If you see in this diagram, what we have done, we have mentioned Azure RM provider, but we have not mentioned anything in version. So when we are going to run Terraform init, it is going to automatically download the Azure RM latest version. Okay. If you do not specify a provider versions in Terraform, it will use the latest available version, which can lead to unexpected behavior such as API changes or new features that may break your infrastructure. I would say today I have initiated a command and it has downloaded a latest version called 4.14.0. Okay. After 6 months, I'm going to run this code again and it is going to download a latest version called 5.14.0. Okay. Do you think our source code it would be 100% compatible with a new version? The answer is no. So in this case, if you're going to run your source code with new Azure RM provider version will get the error. To ensure stability, it is best practice to explicitly define the provider version using the required underscore providers block in your configuration. If you see in this example, what we have done, we have mentioned the version also in our Azure RM provider. So when we are going to run Terraform init, it will download this 4.14.0 version. If after 6 months also, if I'm running the same code, again the same time it is going to download this version. Okay, so let's do a quick demo to understand both these things in detail. I'm going to create a folder name called as demo1 and the second folder I would say demo2. In demo1 I'm going to create a file main.tf. In demo2 also I'm going to create a file name called as main.tf. In this one I'm going to copy the provider configuration from the official documentation. See, I'm going to click on use provider and will copy this. So in demo 1, what I'm going to do, I'm going to remove this version and then I will see the Terraform init behavior. And in demo 2, I will not remove this version, then I will check the Terraform init behavior. Okay, let me copy the path. See, currently I'm in demo 1 folder, so I'm going to run Terraform init. In demo 2 also, I'm going to run Terraform init. If you see here, demo 1 initialization completed. The first message we are getting initializing the backend. We are going to have very detailed discussion regarding this one in our remote state management video. Okay, so we are good to ignore it. The second line it is mentioned initializing provider plugins. Then it is mentioned finding latest version of HashiCorp / AzureRM and it has installed version 4.14.0. Okay. Why it is looking for the latest version? Because in Azure RM we have not mentioned anything related to version. That's why it is looking for the latest version. If we are going to run the same code after 6 months, again it would look for the latest version. Right now I would say it is version 4.14.0. Maybe after 6 months we are going to have version 5.14.0. Okay. If we want the provider versions to be consistent, what we have to do, we have to implement the demo 2 things. What we have mentioned in demo 2, in demo 2 we have mentioned version is equal to 4.14.0. So let's check in our Terraform init. If you see here, we have initiated Terraform init. This one we are good to ignore. And the first line which we are getting, finding HashiCorp Azure RM version matching to this condition, which is 4.14.0. Okay. And it has installed this version, which means in our .terraform folder, we have downloaded this version. Okay. If we are going to run the same code after 6 months, it is not going to check for the latest version. After 6 months, again, it is going to download the same Azure RM version. So this is the benefit of mentioning the provider version. Arguments for specifying provider. There are multiple ways for specifying the version of a provider. Okay, so what we have done in the last example, we have mentioned version is equal to 4.14.0. So when we initiated a Terraform init, it has downloaded this version inside our .terraform folder. But in real time scenario, we do have some other option also. The first option is if we are going to mention greater than equal to 3.0 version. So in this case, Terraform provider version, which is greater than 3.0, it would be downloaded inside our .terraform folder. If 6 is the latest version, 6 version will be downloaded. After 3 months, if you are going to run again, if new version is 7, then the 7 version is going to be downloaded. In second example, it is less than equal to 3.0 version. So when we are going to run Terraform init in .tf folder, any version, I would say the 3 version is available, the 3 version will be downloaded. Okay. If there is, if 3 version is not available, then any version which is lesser than 3 and is available as a provider, it will be downloaded. And the third one is tilt 2.0. Any version in 2.x range will be downloaded. So it will go maximum to 2.99.99, but it will not move to 3.0. Okay. In real time scenario, we generally mention this version configuration. And the fourth example is any version greater than or equal to 3.0 and less than equal to 3.100.0 will be downloaded. Okay, so let's do a quick demo to understand all these example in detail. The first thing I'm going to do, I'm going to create a dedicated folder for it, which is demo 3 and this one. And the file name I will mention main.tf, and then I will copy the provider configuration. Right now the version is 4.14.0, but what is our first example? Our first example is greater than equal to 3.0. So I'm going to paste this value. Let me copy the path and I will run Terraform init. If you see here, the Terraform initialization completed for our demo 3. We are good to ignore this one. The first line which we are getting, finding HashiCorp / AzureRM versions matching with this condition. The same condition which we have passed in our provider version. Obviously, it is going to download the latest version and the latest version is version 4.14.0. In real time scenario, we are not going to mention this one because whenever we are going to run Terraform init, it will download the latest version. So what is the next option we have? Next option we have less than equal to 3.0 version. So in this case, firstly we'll try to download 3.0.0. Okay, if this version is not available, then it will look for the another version, but it would be less than this value. Again, the first command I'm going to run terraform init. If you see here, we are getting an error. Reusing previous version of HashiCorp / AzureRM from the dependency log file, but the 4.14.0 does not match configured version constraint. The constraint value is less than equal to 3.0. Must use Terraform init hyphen upgrade to allow selection of new version. So it is suggesting a command to run which is called Terraform init hyphen upgrade. So till now what we have discussed, whenever we are going to run Terraform init command, we are going to have our .terraform folder. In the .terraform folder, our provider plugins will be downloaded and then in the provider plugins are going to interact with our target API. Okay, this is the part we have discussed. But with .terraform folder, one more file will be created which is called as .terraform.log.scl. Okay, let me explore it. So in this file, the first thing is it is mentioned regarding our provider which is AzureRM, then the version and the constraint. In the last example, what we have mentioned greater than equal to 3. That's why the constraint is greater than equal to 3. And which version it has downloaded? It has downloaded version 4.14.0. Okay. So what is our new requirement? We want to download Azure RM any version which is less than equal to 3.0.0. That's why we initiated a command called terraform init. Terraform firstly tried to use this version, but this version does not match with our new constraint. So we are getting an error. If you want to use a new version inside your provider, then what you have to do, you have to run a command called terraform init hyphen upgrade. When we are going to initiate this command terraform init hyphen upgrade, two of the things are going to be changed. The first thing, it would be our constraint is going to be changed with greater than 3.0.0. It will move to less than is equal to 3.0.0 and the version number, and it is going to download new provider versions inside this .terraform folder. And then going forward, whenever we are going to run our Terraform plan or Terraform apply, whatever the version number mentioned in .terraform.log.scl, the Terraform plan and Terraform apply is going to use it. Okay. If we are going to change again the Terraform provider version, Then again we need to run a command called terraform init hyphen upgrade. Then automatically our .terraform.log.scl file will be updated and the new provider version will be downloaded inside .terraform. So let's run the command. Okay, I'm going to run terraform init hyphen upgrade. There's one typo. I'll run terraform init hyphen upgrade. See, the initialization process has started. So Terraform initialization completed. The first thing which we are able to see, finding HashiCorp / AzureRM version matching to this condition and installing HashiCorp AzureRM version 3. So as I have mentioned, the two of the things are going to be changed. The first thing is our .terraform.log.scl. It has updated the constraint from greater than 3.0.02 less than is equal to 3.0.0. Okay. And with this condition, it has version 3. And the second thing which we have discussed, it is going to download this version inside our .terraform folder. Let me click on it. See, see, currently we are having version 3 and version 4. And whenever we are going to run Terraform plan apply, it is going to use version 3 to connect with our target API. Okay. And in future, if you want to use version 4, what we have to do? We have to update in Terraform provider version and then again we need to run a command called terraform init hyphen upgrade. In this hyphen upgrade part, again our version will be updated and constrained and it is going to use this one for all our Terraform plan and apply. Okay. So our third example is to use till 2.0. Let me copy this one and paste this one inside. So in this case, what we are going to see, it will only update the minor version or patching. It is not going to upgrade the major version, which means it will download any Terraform provider version within a range of 2 only. Okay, but it is not going to download any Terraform provider version from version 3. It will only download within a 2 range. If I'm going to mention here as 3, so any version which is within a range of 3 only it is going to download. It is not going to download 4. This one is generally used in real time scenario. If you are going to mention this one, it is going to upgrade only my minor and patching. It is not going to upgrade my major versions. Okay, let me run terraform init hyphen upgrade to check the new provider version. That's it, terraform init hyphen. If you see here, Terraform init hyphen upgrade completed and it has downloaded the version 2.99.0 but it has not moved to the major upgrade which is version 3. Okay, this is a benefit of using till 2. See, in our .terraform folder, the new version is also downloaded. So when we are going to run Terraform plan or Terraform apply, so this version will be used to connect to our target API. Okay. Let me quickly change this one 2 to 1 and let's see. See what I have done? I have changed the condition from 2 to 1. So the constraint is this one. And so the last version of 1 is 1.44.0, which means after 1.44 they move to version 2. Okay, that's why it has downloaded version 1.44.0 And let me check in .terraform folder. See, it has downloaded this one. Again, the same thing. Going forward, whenever we are going to run Terraform plan and apply, it is going to use this. And our last example is greater than 3.0.0 and less than 3.100.0. Okay, let me paste the value. Again, if I'm going to run Terraform init, we'll get the error. Let run. So let's run Terraform init hyphen upgrade. Again, the same thing will happen. Firstly, it is going to update our .terraform log.scl file, and then it is going to download the provider version in .terraform. Okay, see, finding hashing of AzureRM version matching greater than 3.0.0 and less than 3.100.0, and the version is 3.100.0. And see, and let's check in our .terraform folder. This version has been downloaded. Okay, so with this we have completed this. Hi everyone, in this video we are going to discuss about Terraform state file. So what is Terraform state file? Terraform state is essential for managing your infrastructure. It acts as a kind of database for your Terraform project configuration. When it is created, the terraform.tf state file is automatically created by Terraform when you run Terraform apply for the first time. It is stored in the same directory as your Terraform configuration files. Next time, if you run the Terraform apply, every subsequent Terraform apply will update this state file with the latest information about your infrastructure. So let's take example. We are working on project A and we have created a dedicated folder with a name called A. In this project, we are creating one resource group, the storage account, and the virtual machine. What is our end goal? Our end goal is to create the resources in Azure. So once we are going to run our Terraform apply command, two things are going to be happen. One, it would be like creation of the resource. Second thing, it would happen like our state file will be created. This state file is a kind of database. What is the exact meaning of database? It will has all the information about all the resources which we do have created in our Azure account. Next time, if you are going to update, I would say with in our storage account and virtual machine, if you miss to update the tags, and next run what we are doing, we are updating the tags in the storage account and virtual machine, and we are running a Terraform apply, it will be created, and parallelly our state file will also be updated. Okay, and when we are going to destroy all these resources, the resources will be destroyed and the state file will also be updated. So state file, I would say, it is a kind of database which is store the information about the project A, what are the resources we are creating, and the other configuration. We are going to have a very detailed discussion in the next video about the state file requirement in terms of current state and the desired state. Contents. It contains information about the resource managed by Terraform, including their attributes, dependencies, and metadata. As I do have mentioned, this state file will have all the information regarding our resource group, storage account, and virtual machine details. Storage. The state file can be stored locally or remotely, depending on the configuration. Common remote state backends include Amazon S3, Azure Blob Storage, Hashicorp Console. By default, where the state file is going to be stored, it would be stored in our local machine from where we are running our code. But apart from that, we do have other options. I would say remote state management option where we are good to store our state file in a remote storage. We do have a dedicated video to discuss about this one. Locking. Terraform state file support locking mechanism to prevent concurrent modification, ensuring only one user can apply changes at a time. Yeah. So by default, Terraform provides us the locking behavior. Right now, we are managing the things from our local machine, so it is not required. But in real-time scenario, when we are going to work in a team, at that time, the locking behaviors plays a very important role. I would say We have put our state file inside the Azure storage account. Okay, and we are having a team A member and team B member. Both of them try to do the changes. If the Terraform is not going to support the locking behavior, the user A and user B is going to update the state file can be corrupted. So in that case, what Terraform is providing, if the user A has initiated the thing for his operation, the state file will be locked. And once his task completed, then the lock will be removed and then the user B is good to do the changes. Okay. With this, we do have completed the Terraform state file discussion. In the next video, we are going to do a quick demo about when the state file is going to be created, what would be the impact if we are going to do any changes, and the other configuration. We are going to do a quick demo on a state file. So what I have done till now, I have created two file name called as providers.tf for my provider configuration, and then I'm having a storage.tf. If you see in storage.tf, the first resource which I'm going to create, it is my resource group, and the second resource which I'm going to create, it is for my storage account. So what we are going to do, the first thing, we will apply the resource, means create the resource in Azure. Once this resource is created, we will check the status of the state file. Is it created or not? The second thing which I'm going to do, I'm going to update the things in terms of, I would say, tags in our RG, and we'll check the state file status. And the third thing which I'm going to do, I'm going to delete the resources, and then I will check what is the status of the RG. So we are going to do three cases: case 1, case 2, and case 3. Okay, so let me start the demo. So I'm going to run Terraform init. Then I'm going to run Terraform plan. Plan has generated a two of the resources is going to be created. One it to do my resource group and the second it to do my storage account. Still we are not having a state file. Let me run Terraform apply. And I'm going to type yes. So if you see here, two of the resources has been created. Let me quickly check inside the portal. The resource group name is example-resources 234. If you click on resource groups, see the resource group has been created and our storage account is also created. Parallelly, we do have one file name called terraform.tf state. Let me maximize it. So in this terraform.tf state, it has all the information regarding the Terraform version which we do have used. Is there any output blocks? We are going to discuss in our upcoming videos what is the output blocks and detailed information regarding the resources. It has the subscription detail, then it is name of my resource group. The tags we have not updated, so that's why the value it is coming here as null. Okay. So we do have created our storage account also. See, it is mentioning AzureRM storage account with the other configuration details. Okay. So once, so for the first time when we are going to run Terraform apply, it will create the terraform.tf state. So the second thing what we are going to do, we are going to update our TF configuration and then see what it is going to happen. So right now in the tag, it is mentioned as null. Okay, so what we are going to do, we are going to update the values in our Terraform configuration and see whether the state file is updated or not. So I'm going to mention here as tags is equal to environment and created underscore by is equal to, I would say, a comma. So I've saved this Terraform configuration and see Terraform apply. I'm going to mention. So the Terraform apply command has started. And if you see here at the right, we are having a file name called as .terraform.tfstate.log.information. In this file, we are having a metadata about the user who has initiated this request. And due to this file, our Terraform state file will be logged. And if any other user wants to do any changes on this resource, they would not be able to do it. Okay, they'll get an error. If you see here, what it is showing like we need to do some changes. If I'm going to parallelly copy the path, and I'm going to run Terraform plan, see what we have done. We have initiated Terraform apply. Okay, and we have not passed the value here. So right now what the Terraform has done, it has created a file name called as .terraform.tfstate.log.information, and this is my user detail only. Okay, and parallelly what I have done, I have opened one more CMD, and in this CMD what I'm doing, I'm running Terraform plan command, and when I'm running the Terraform plan command, I'm getting an error acquiring the state log. So whenever any user is going to run a command called terraform apply, or I would say terraform plan. If the terraform.tf state is locked, then he will get this error. Okay, and this lock is coming from due to this one. This file has detailed information from the user end who has initiated it. So this is an overview about what is the purpose of .terraform.tf state.log file. So I'm going to type yes. So what we are doing, we are updating the resource group tags, and it has initiated the process, and our tags has been updated. I'm going to click on, let me refresh it. If you see here, the tag has been updated for our resource group, and parallelly let me check my state file also. The state file, see, initially it was coming null, but right now the tag has been updated. Terraform apply operation has been completed, and we have made the changes. If you see, we are not able to see any file with a name called .terraform.tfstate.log.information. It has been released. If I'm going to run Terraform plan again, I will not get the error. See, we are able to fetch the information. It is clearly mentioned no changes. Your infrastructure matches the configuration. Why? Because why we are able to do so? Because this task has been completed. If, as I do have mentioned, a command called Terraform apply and it is in progress, and then from the parallel CMD, if I'm going to open it, then I'm going to get this error. Okay. So what we have discussed till now, the first thing we discussed, like creating of resource group and storage account. Okay, this has been completed and it is a first time run. So our TF state file created. The second time what we have done, we have updated the tags. So once we update our tag, Then the state file is also updated. The third thing which I'm going to do, the third thing I'm going to destroy the resource. So once we are going to destroy the resource, definitely it is going to delete the resource from our Azure subscription. And once it is deleted, it is going to update my Terraform state file also. Let me show it quickly to you. Again, we have initiated some command. You see the .terraform.tf state.log file has been created, and it will have all the details regarding the user who has initiated it. I'm going to type yes. What it is going to do? It is going to delete both of my resources. And once this resource is going to be deleted, what we are going to see? We are going to see the details about the Terraform state file. So meanwhile, we are good to discuss about this one also. As I do have mentioned, once the Terraform state file is created, it is going to create one more file with the extension of .backup. It will has all the details of terraform.tf state. But if any case, if Terraform state file is corrupted or any issue happen, in that case, we are good to update this backup file. We just need to remove .backup configuration from it. If you see here, both the resources has been destroyed. See, inside the Azure portal, we are not able to find any resource group with the name of example resources 234. Parallelly, let me check with the Terraform state file. The Terraform state file will also not have any details. Okay, because we have deleted the resource. I would say I'm having a project name called Terraform project. Okay, folder. And in this Terraform project folder, I'm going to create multiple project. I would say project A, project B, and project C. In each and every project, I would say project A, project B, and project C, I'm going to create n number of resources. Okay. So whenever I'm going to run Terraform init, plan, apply, whatever the things I would say .terraform log.scl, terraform.tf state, it will be created inside this folder only. The same thing it would happen for project B. If I'm going to run Terraform init, plan, and apply, whatever the add-on I would say file, it would be created inside this B folder. And the same thing it would happen for C folder also. Okay. So in each of the folder, we are going to have our dedicated state file, or I would say dedicated .terraform file, .terraform log.scl file. Okay. If inside this one, if this is the file folder which I do have created with a name called state file underscore demo, inside this one, if I'm going to create more folder called project underscore A, and inside this project A, I'm going to create a file name called as providers.tf and storage.tf, and I will copy this one. Okay. I'm going to run Terraform init. So if you see in this case, what it is doing, it is creating a new folder called .terraform. It is not fetching the value from its parent folder state file demo. One. Approve. So in the same way, we are going to have our dedicated TF state file present inside project A. It is not going to use the state file which is present inside the parent folder. Let's wait to complete it, then I will show you. If you see here, our resource group and the storage account has been created. Let me quickly refresh it and see the storage account and the resource group created. But the it is it has not used the terraform.tf state or .terraform folder or .terraform log.scl from the parent one. Instead of it, it has created a new folder for our .terraform, .terraform log.scl and .terraform.tf state. Let me show you inside the folder. If you see here, we are having a I have opened a state file demo. Here we are having .terraform, and .terraform log.scl .tfstate and .terraform .tfstate .backup. While in this folder, I do have created one more folder called name as project underscore a, and in this project a, it has its own .terraform .logcl .terraform log.scl and tfstate. So what is the exact meaning of it? It means if you are going to create a folder name called as project folder underscore folder, and in this one, if you are going to have multiple folder a, b, and c, when you're going to run Terraform init, plan, and apply, the dedicated file will be created inside this one. And inside this A, if I'm going to create one more folder, a child folder, I would say double A. And if you're going to run Terraform init, plan, and apply, it will not use this uh, Terraform file. It is going to create a new .terraform file or tfstate or log.scl. With this, we do have completed. Hello everyone. In this video, I'm going to discuss about the desired state and the current state. So what is the exact meaning of desired state? Terraform primary function is to create, modify and destroy infrastructure resources to match the desired state described in the Terraform configuration. So whatever the things we do have mentioned in our .tf file, it is called as desired state. Okay. What are the operation we are good to do? Create, modify and destroy. So what is the exact meaning of current state? Current state is the actual state of a resources that is currently deployed. So what is the exact meaning of it? Whatever the resources we do have created inside portal.azure.com, it is called our current state. Important point. Terraform tries to ensure that the deployed infrastructure is based on the desired state. If there is a difference between the two, Terraform plan presents a description of the changes necessary to achieve the desired state. So as we do have discussed in the last two slides, desired state is the thing which we do have mentioned inside our .tf file, and the current state is the resources which are created inside our portal.azure.com. Cases for desired state and the current state. What would be the impact on plan and apply? Resource group creation initiated through Terraform. So what we have done in our Terraform configuration, we do have mentioned like, hey, one of the resource group is going to be created. So what would be the plan? One resource group creation it will show. On apply, one resource group will be created. While in the second case, resource group already created manually, then run Terraform with the same name and location. So what is the exact meaning of it? Like we do have created the resource group inside portal.azure.com using manual approach, I would say, or PowerShell approach or ARM template. So what will be the impact on plan? One RG creation, apply. At apply time, it will give us the error. Why? Because the resource group is already present inside our portal.azure.com. In the third case, resource group created through Terraform and a tag manually added from the Azure portal. What we have done, we have created a resource group using Terraform and we have added a tag manually from the Azure portal. So in the plan, it is asking to null the tag's value as it is not mentioned in the desired state. While apply, it will remove whatever the things we do have mentioned. It means whatever the tag we do have added through manual approach, it will be removed and then the desired state and the current state will be matched. Resource group created through Terraform and then deleted from the Azure portal. So in this case, what we have done, we have created a resource group through Terraform and deleted from the Azure portal. So in the next time, whenever I'm going to run a Terraform plan, it will asking us to create a new RG, means whatever the RG has been deleted and the new RG will be created. So in the next video, I'm going to do a quick demo on all these four test cases. Okay. Hi everyone, in this video we are going to do a quick demo on the cases which we have discussed in the last video. So the first case is we are going to create one resource group and we are going to implement the plan and the apply and see what is going to happen inside our portal.azure.com. Okay, so let's start. So what I have done, I have created a one file name called as main.tf and parallelly a providers.tf. This main.tf is responsible to create a resource group name as example in the location called West Europe. Let me copy the path, Terraform init. Initialization completed. I will run Terraform plan and then Terraform apply hyphen auto approve to save the time. As mentioned, this plan is basically responsible to create the resource group name as example in the location called West Europe. If you see here, our resource group has been created successfully. Let me quickly check inside our portal.azure.com. So what is the name of the resource group? The name is example. So this is the resource group which has been created in the location, I would say, West Europe. So that case one has been completed. So what is the case two we do have discussed? In the case two, what we are going to do, we are going to create one resource group using manual approach. It can be anything, I would say PowerShell, or I would say using ARM template, or using Terraform also, but in a different folder, like in a different state file. Terraform using a different state file. Okay. And then once this first part completed, what we are going to do, we are going to write a resource group creation task using Terraform, and then we will run plan and apply to check what are the configuration we are going to have in the plan stage and the apply stage. So let's check the case 2 condition. If you see main.tf, what we do have mentioned, the resource group name is example hyphen resources. I will create it. I'll mention example hyphen resources, and the location I'm going to mention is West Europe. And I'm directly going to mention review and create. So our resource group has been created example hyphen resources, and it has been created manually. So what is the second stage which we are going to do? I'm going to copy the path. I'm going to run Terraform init. The next step, it is all about Terraform plan. If you see here in the Terraform plan, what is showing? It is going to create one RG for you. What are the challenges we are going to have in Terraform apply? Because this resource group is already present inside the portal.azure.com. If you see here, we are getting an error. So what is the exact meaning of this error? This a resource with ID, which is mentioned here, example hyphen resource, already exists. To be managed by Terraform, this resource need to be imported into this state. Please see the resource documentation for AzureRM underscore resource underscore group. Regarding this import command, we are going to discuss in detail in our upcoming videos. But what is the main challenge we are seeing right now? The resource group name as example hyphen resources is already present inside the portal. And again, we are trying to create the same resource group using Terraform. We are getting an error. In terms of plan, it was okay. Okay. But when we implemented Terraform apply, at that time we are getting an error. So what is the exact meaning of it? If the resource is already present or created inside portal.azure.com, and when we are going to run Terraform init plan and apply, at the plan time we are going to get the error. Okay, so let's discuss the third use case. So in the third use case, what we do have discussed, we have created the RG. Okay, and in this RG we have not added any tag, and this thing was created using Terraform. Okay, so the next thing what we are going to do, manually we are going to update the tag here, and then we are going to run Terraform plan and apply to check whether it is matching to the desired state or not. Okay, so let's do it. Here we do have the resource group name as case-3 and the location is West Europe. Let me copy the path. I have initiated a command called Terraform init and then Terraform plan. If you see here, it is showing what? To create a resource group name as case-3 and the location is West Europe. Let me run Terraform apply hyphen auto hyphen approve. Okay, there's one typo. If you see here, our resource group has been created successfully. Let me quickly check inside the portal, and our resource group name called case-3 has been created. But in this code, we haven't mentioned anything related to tags. So what we are going to do, I'm going to manually update the tags. I would say environment name as dev created underscore by, I would say A Kumar, and let me save it. Okay, our tag has been updated. So what would be the next step? The next step it would be, I'm going to run again the Terraform plan to check it. If you see here, we are getting a message. What? To move this created underscore by is equal to A Kumar value to null, environment is equal to dev to null. Why it is happening? Because in our desired state, we have not mentioned anything regarding the tags. While in the current state, we have updated the tag using a manual approach. So in the last video, what we have discussed, at any time desired state is going to get a preference in comparison to the current state, and it should be always equal to the current state. So to match the desired state and the current state, it is asking to remove all the tags whatever we do have updated manually. Okay, so let me run Terraform apply here and see what is going to happen. If you see here, one of the things has been changed, which is our tags. And let me quickly refresh and see, is it the tags are still present or not. Let me refresh from the top and see. The tags are not present. It has been deleted. Okay. So what is the exact meaning of it? So desired state should match to the current state. If in the current state we are going to do any changes, in the next run of Terraform plan or apply, it is going to undo it. Whatever the things we do have mentioned in our desired state. What I'm going to do, I'm going to update the tags here. If you see here what is showing, it is showing to two of the tags are going to be updated, which is created by and the environment. See, it has been completed. Let me quickly check inside the portal.azure.com. Let me refresh from the top and see the two of the tags has been updated, created by and the environment. Okay. So what is the exact meaning of it? At any time, desired state should is equal to the current state. If we are going to do any changes, I would say in current state, in in the next run of Terraform plan and apply, it will be equal to the desired state. If we are going to do any changes in desired state, so in the Terraform plan and apply, it will try to implement it. Okay. If I'm going to delete both the tags and save, so in the next run, I'm implemented Terraform apply hyphen auto hyphen approve. So in the desired state, we do have mentioned A Kumar created by is equal to A Kumar and environment is equal to dev, and we have deleted both the tags. So in the next run, what is what it is going to do? It will update both the tags. Okay, let me refresh it and show to you. See, both the tags has been updated. So what we do have discussed in case number 4. In case number 4, we are going to create this name resource group name called as case hyphen 4, and I'm going to delete this one from the portal.azure.com. Then I'm going to run Terraform plan, Terraform apply. Okay, let me run Terraform apply hyphen auto hyphen approve. So it is going to create a resource group name as case hyphen 4 in a location West Europe. So our resource group has been created. Let me quickly check inside the portal. Let me refresh it. If you see here, the case hyphen 4 has been created. So what we are going to do, we are going to delete this resource group. So resource group case hyphen 4 has been deleted. So what we are going to do, I'm going to run Terraform apply. So in this case, what it is going to happen, we do have our desired state, which you do have mentioned, and then what we are having our current state. In desired state, we have created, I would say, case hyphen 4 resource group, and in the current state, which is inside our portal.azure.com, we have deleted this one. So when we are going to run the next Terraform plan or apply, it will check whatever the things we are having inside our terraform.tf state, is it matching or not. So currently it is not matching, the desired state is not matching to the current state, so it will ask like, hey, we need to create this resource group. So that's why it is showing here we need to add one rg. Let me type yes. So what, so our resource group again has been created inside our resource group. Okay, so with this we have completed all the 4 cases which we do have discussed in the last video for the current state and the desired state.